Dear students, in regular classes, we completed the third unit. But so last topic in the third unit was not completed in the regular classes. So in this video, I explained the topic because the topic is important. So it is an expected question in the external examination. That is effect of open loop poles and open loop zeros to the root locus. So that means what happened when open loop poles and open loop zeros are added to the root locus. Either the root locus shifting towards the right side or left side. So now we will discuss. First one is adding of poles. What happened when the poles are added to the root locus? So when the poles are added to the root locus shifted towards the right half of the S-plane. Either it is correct or not, we can see. Consider the function g of s into h of s is equal to k by s into s plus 2. So now I want to draw the root locus for this function. So this is the root locus for this function. Here the function having two poles that are s is equal to 0 and s is equal to minus 2. So that two poles are located in the s plane and draw the root locus. So the root locus is like this. So one root locus branch starts at s is equal to 0 and traveling like this and moving towards the infinity along with plus 90 degrees azimuth. And another root locus branch starts at s is equal to minus 2 and traveling like this and traveling towards the infinity along with minus 90 degrees azimuth and taken a breakaway point here like this. So this is the root locus for the function k by s into s plus 2. Now I want to add one pole to this function, that is s is equal to minus 4. That means now the function g of s into h of s is equal to k by s into s plus 2 into s plus 4. The root locus for this function is like this. So this is the root locus for k by s into s plus 2 into s plus 4. So here the root locus is shifting towards the right half of the s-plane. So in case 1, the root locus cannot touch the imaginary axis. But in case 2, the root locus touching to the imaginary axis. So that the system stability is reduced than compared to the first case. Now consider the third case. But this is the second case. Now consider the third case. The third case, one more pole is added. That is s is equal to minus 6 is added to the root locus. Now the function g of s into h of s is equal to k by s into s plus 2 into s plus 4 into s plus 6. Now I want to draw the root locus for this function. The root locus for this function is like this. So this solid line is the root locus for case 3. Now this dotted line is the root locus for the case 2. Now compared to the case 2 and case 3, so what are the differences? First difference is the breakaway point is moving towards the imaginary axis. So this is the case 2 breakaway point. This is the case 3 breakaway point. So that the breakaway point is moving towards the imaginary axis. So that the system stability is reduced. Here the root locus touching to the imaginary axis, then compared to the previous case, this value is less. So that the system reduces the stability when compared to the case 2 and case 3. So why? Because the root locus is shifting towards the right half of the s-plane. That means if any root in the right half of the s-plane, the system is unstable. Already we know. So when the system is stable, when the system is unstable, when the system is marginally stable. If the roots of the characteristics are lies left half of the imaginary axis or s-plane, the system is stable. If the roots of the characteristics are the given function are present in right half of the s-plane, the system is unstable. If the roots are present on imaginary axis, then the system is limitedly stable or marginally stable. So that here, when we are adding the poles to the root locus shifted towards the imaginary axis or right half of the s-plane. and reducing the stability of the system. So finally we can summarize. So from this we can conclude that due to the adding of poles, the root locus shifted towards the right half of the S-plane so that the system stability decreases. So finally we can conclude what are the changes when we are adding the poles to the root locus. The first one, root locus shifting towards the imaginary axis. That is the first one. Second one, system stability relatively decreases. Third one, system becomes more oscillatory in nature. Fourth one, range of the operation of a K value for the stability of the system is decreases. So these are the main changes when we are adding poles to the root locus and adding of zeros. Next one, what happens when the zeros are added to the root locus? Either the root locus again shifted into the right side or shifted into the left side of the imaginary axis. We can see. Let us consider the pole, sorry, 0. Let us consider the 0 s is equal to minus 4 to the function g of s into h of s is equal to k by s into s plus 2. Already we know the root locus for k by s into s plus 2. So this is the root locus for k by s into s plus 2. Already this root locus is shown in adding of poles also. That is k by s into s plus 2 function. So this is the root locus for k by s into s plus 2. Now I want to add 1 0, that is s is equal to minus 4 0 to this root locus. Then the function is, so here the zeros are added. We know zeros are present in numerator and poles are present in the denominator. So that previous case the poles are added in the denominator. Now zeros are added so that these zeros are added in the numerator. So the function can be changed as k into s plus 4 by s into s plus 2. So now the function is g of s into h of s is equal to k into s plus 4 by s into s plus 2. Now I want to draw the root locus for this function. So the root locus for this function is like this. So here two poles are there, 1 0 is there, s is equal to 0 1 pole, s is equal to minus 2 1 pole, s is equal to minus 4 1 0. So one root locus starts here traveling like this and second root locus branch starts here traveling like this. Why? Because here between the two poles there is a root locus on the imaginary axis, so that breakaway point is there. So this is the breakaway point and one branch is moving like this and second branch is moving like this, and one branch having the sufficient 0 so that one branch is included in this 0 and another branch is not having the 0 so that another branch is traveling towards the infinity along with negative real axis. So this is the root locus for k by s plus 4 by s into s plus 2. Now compare these two cases. First case is k by s into s plus 2. Here the root locus traveling towards the infinity along with plus 90 degrees minus 90 degrees azimuth. Now in this case the root locus traveling are moving away from the imaginary axis. This is imaginary axis. This root locus moving like this, so that this root locus is moving away from the imaginary axis. And consider one more example. Let us s is equal to minus 6 0 is added to this function. Then the function is k into s plus 4 into s plus 6 divided by s into s plus 2. So this is the function. Now I want to draw the root locus for this function. So this is the root locus for this function. So this dotted line is the previous root locus. This solid line is the present root locus. Then compared to these two, the breakaway point from compared to the previous and present case, the breakaway point is moving away from the imaginary axis. This is imaginary axis. The initial or previous case, the breakaway point is this one, and Now present breakaway point is this one, so that this breakaway point is shifted to here, so that this breakaway point is moving away from the imaginary axis. So, and the root locus bend away from the imaginary axis. If the root locus is bent away from the or moving away from the imaginary axis, the system is more stable. If the root locus moving towards the imaginary axis, the system is unstable. So finally we can conclude what happened when the open loop zeros are added to the root locus. Due to adding of zeros, so towards left half of the S plane, system stability increases, so that the root locus is moving or bend towards the left half of the imaginary axis and away from the imaginary axis. Uh, then the system is more stable. That means system stability increases. So what are the differences while we are adding zeros to the root locus? And the first point is root locus shift to left away from the imaginary axis, so that the root locus is shifting away from the imaginary axis. That means away, that means moving towards the left half of the imaginary axis or S plane. Second one, relative stability of the system increases. Third one, system becomes less oscillatory. Fourth one, range of operating of the value of k for the system stability increases. Compared to poles and zeros adding to the root locus, when we are adding pole, the root locus shift away from the towards the imaginary axis. When we are at zero, away from the imaginary axis, quite opposite. Second one, when we are adding poles to the root locus, the relative stability of the system decreases. When we are adding zeros, the relative stability of the system is increases, quite opposite. Third one, when we are adding poles to the root locus, the system becomes more oscillatory. Now we are adding zeros, the system becomes less oscillatory, quite opposite. Fourth one, the range of operating value of k for the system stability decreases when we are adding poles. When we are adding zeros, the k for system stability increases. So the 4 points are quite opposite when we are adding poles and zeros to the root locus. So finally, what are the advantages of root locus method? Already we discussed in regular classes some advantages are there in root locus, so that we go for the root locus. Otherwise, if there is no advantages in the root locus, RH criteria is sufficient. So some drawbacks are there in RH criteria. We want to overcome that drawback, we go for the root locus. And root locus having some own advantages. So these are the advantages for the root locus. So these are the advantages of root locus. So first one, the absolute stability of the system can be predicted from the location of the root locus in S plane. That is the first advantage. Second advantage, limiting the range of the value of the system gain k can be decided from the absolute stability of the system. Third one, using the root locus, value of the system gain k for any point on the root locus can be determined by using the magnitude condition. Next one, for particular damping ratio of the system, gain k can be determined, which helps to design the system more correctly. Finally, gain margin of the system can be determined from the root locus. Phase margin of the system can be determined from the root locus. In third unit, I am not explained gain margin and phase margin of the system. These two are clearly explained in the fourth unit, that is frequency response. In that I will explain the gain margin, what is the gain margin and what is the phase margin. So this is the advantage of the root.